Welcome to Pomodoro Joe for Thursday, April 6th, 2023. Today we're doing LeetCode problem 1254, number of closed islands. It's a medium problem. All right, let's see what this says. Given a 2D grid consisting of zeros land and ones water, an island is a maximal four-directionally connected group of zeros. And a closed island is an island totally all left, top, right, and bottom, surrounded by ones. Return the number of closed islands. Okay, so in this problem, we are given a 2D grid, and in this grid, we have zeros and ones. Zeros represent land, ones represent water. We're looking for all of the islands in this grid. Now, an island, they're calling them closed islands, but a closed island is essentially land that is completely surrounded by water. So in this example, we have this closed island here. This is all land surrounded by water. We have one closed island here surrounded by water. Now, they're just looking at the cardinal directions, up, down, left, and right. The diagonals don't count. So this one is land, or this one here is an island, and this grouping is an island. All of the other things are not considered islands. So like these zeros here, not an island, this zero, not an island. So this is 2. And the answer is 2. In this example, same kind of thing. We have a bunch of land that's connected to the edges of our map, but those are not going to be considered islands. Only this one here is considered an island because the cardinal directions are all water. And there's another example, but they don't really go through it. All right. So we'll put 25 minutes on the Pomodoro timer and we will get started. So this is a standard grid traversal type problem. Now, grid traversal problems are something that you'll find a lot in LeetCode. Sometimes you'll find them in interviews. I've been asked grid type problems in a couple interviews. I myself, as an interviewer, I've never asked a grid problem because personally I don't think they are a great demonstration of somebody's coding ability. But regardless, you may run across these types of problems in an interview, so it's worth studying them and understanding them. So there's certain components that you'll see in a grid traversal problem over and over and over again. Now the basic components are you'll need some list or some stack of all the grid squares that you'll need to traverse. You'll also need to keep some record of which squares you've already visited. And then you'll have to do whatever the algorithm's asking you to do. In our case, we're looking for islands. So we'll have to find what are our conditions that specify we've found our island. Okay, so we will start with some result and we'll set it equal to 0 to start with. We might have 0 islands and we'll return our result at the end. So we'll just be counting islands and adding them to our result as we find them. So in our grid traversal, I'm going to use a queue or a stack. It doesn't really matter. You can call it whatever you like. With a queue, it's basically first in, first out, and this will be a breadth first search. It doesn't really matter in this case, but that's the approach I'm taking. So I'll need a couple things. I'll need my queue. I'll need something to keep track of which squares I've already visited. So I'll have a visited set. I like using sets for that kind of thing. So I'll have a visited set. And then I'll just go through all of our cells looking for our conditions. Now, what conditions am I looking for? So it appears that I'm looking for all these land squares that are not connected to the edge of the map. So I think that's my only condition. As long as I have land that's not connected through other land to the edge of my map, then I know it has to be surrounded by water. As soon as it's connected to the edge of my map, no luck. That thing is not going to be an island. So I'll go through our grid starting at 0, 0. We'll just keep going through till we find some land. Once we find land, then we do our grid traversal where we are going to say, let's find all of the land that's connected to this land. So we'll look up, down, left, and right, put those cells onto our stack or into our queue. Then we'll traverse through all of our land cells. If we run out of cells without ever touching the edge of our map, well, then that's going to be an island. If we end up somehow connecting to the edge of the map, well then it's no longer an island and we can just ignore the whole land, the whole set of connected cells. All right, so let's do our traversal. I think I'll want a couple helper variables here. So I'm going to keep track of my maximum, my max x and my max y. So max x. This is also something you'll probably want to get practice with, knowing what are my dimensions in my grid, which way is x, which way is y, which variables are going to be first, like when I index into my grid. So I'm going to use screen space type coordinate systems where my 0, 0 is in the upper left, and x will increase as you go right, and y will increase as you go down. So my x will be essentially the number of columns I have in each row. And so that's going to be the length of my grid at row 0. I'm going to subtract 1 because the length of the grid is how many elements are in the grid, but I want the maximum x as a coordinate, so that's going to be the max index, and that's going to be 0 indexed or 0 based, so I need to subtract 1. Then I have my max y, and that's going to be just the length of my grid, and that's how many rows I have. And again, I'll subtract 1 just to keep my indices 0 based. Okay, so now I have my maximum x and my maximum y in my grid. Those are going to be helpful later on. Now the other thing I'm going to want is some way to keep track of which cells I've visited. So I'm going to keep a visited set. So now a set is just a way to keep track of unique values. Okay, so I have my visited set. Let me spell visited right. And now we get to our, so this is actually going to be sort of a two-part traversal. One part of the traversal is just going through every cell looking for land. Then when we find land, we'll check which connected cells are land and see if that land is connected to an island or not. So two-part traversal. One part just for every x and y we're going through looking for land. The other part, once we find land, then we'll go through and check all the connected cells. All right, so I'll go through y, well, I'll do x, why not? For x in range, length, actually, I've already got my max x, so I can say max x, but I need to add 1 because in range, it is non-inclusive. It will exclude the last value, and I need this to go all the way to the end. So I have to say x in range, max x plus 1. And then for y in range, max y plus 1. All right, so what's next? I guess there are two conditions that I can look for here, where if this is not land, if this is just a water cell, I can ignore it, or if I've already visited this cell, then I can just ignore it. So let's check those two conditions first. All right, so if my grid at this coordinate is equal to 1, meaning it's water, I can ignore it. Or if, let's see, I'm going to store these as tuples, so my xy coordinate is already in visited. Then I can ignore it and I'll continue. Now you might notice I left out my actual x and y here because I want to make a point of demonstrating what these are because they're going to be counterintuitive. So this grid is row first and then column. Now our rows are the y values. So the y will increase as we go down, and that's each row. So we have to do grid at y and then x. So it's kind of counterintuitive, but once you learn it, you get used to it, you'll just be a natural at this. All right, so if our grid at yx is equal to 1, meaning it's water, we'll just ignore this. We're looking for land. Or if we've already visited this cell, we can ignore it too. All right, if we haven't visited this one and it's not water, so now we found some new land. We want to check to see if this new land is an island. So if is island, and we'll pass in this xy coordinate. Actually, I can pass it in as x comma y. There we go. So if this is an island, then we can increment our result and keep going. That's pretty straightforward, except we need to define our function isIsland. This is where it's going to get a little bit trickier. All right, so here's our isIsland function. We'll take some x and y. So that is just our starting position. We'll be traversing through all the connected land to this current x and y. So to do this, we'll have some result. Now this result is our internal result saying whether or not it's an island. So we'll start it off saying it's true. We'll just assume this is an island. At the end, we will return that result. Now we need to keep track of which pieces of land that we still need to traverse. So we'll have some Q. That's going to be just a list or an array of all of our coordinates. So we'll start it off with our current XY coordinate. All right. Now, while we still have something in our queue, so the plan here is we'll start our queue with our current x and y. We'll pop every cell out of our queue or every set of coordinates out of our queue, then traverse that coordinate, check to see if we have surrounding land. If we do, we'll put that surrounding land, we'll check up, down, left, right. If we have land in those cells, we'll put those into our queue. Then we'll not recurse, but then we'll continue our loop. We'll pop the next cell. So essentially what we're doing is checking every cell, finding all the connected land, pushing those onto the queue. Then we'll be checking those, checking all the surrounding land, pushing that land onto the queue until we run out of land to check. All right, so our cell will be q.pop. I'm going to pop at 0. So our new x, let's see. That's going to conflict with this x and y. Let's call this, I'll call it start x. There we go. Now, I could use x and y internally here, and it wouldn't really be a problem, but I don't want it to be confusing, so I'm going to actually create start x and start y here. Okay, so we pop our cell. Now, this is probably better, I could say chords. So our x is going to be coordinates at 0, and our y will be coordinates at 1. Chord. So one thing you'll note here too, I'm storing these as x, y in that order, x, y, because it's natural to think of coordinates as x, y coordinates, but when we use them, we will be using them as y, x when we access our grid. Okay, so now we have our coordinates x and y. We can check if our x, so if this grid is water, then we can ignore it. All right, so if this grid cell is water, let's just move on. We're looking for land. So there are a couple conditions that we're looking for that we can ignore. So if we've already seen this cell, then we can ignore it, or if this cell is water, we can ignore it. Those are our two main conditions. So our first one here, we've said, is this a water cell? Let's continue if it is, or let's ignore it if it is. The other thing we'll check is if this coordinate, that's in our visited, then we've already seen this land before. We don't want to continue going down this path, so we'll continue. No. So if our coordinate is in our visited group, then we'll just continue, because we've already seen this land before. We don't need to check it out again. Okay, so this handles our two cases of water or land we've already seen. Now if we get past those two checks, we're at some new land, we haven't seen this before. Let's just check to see if this land is connected to the border. Because if it's connected to the border of our map, then we know this is not an island. So we can set our result to false and move on. So we can check if it's at the border by just checking if our x coordinate is greater than or equal to our max x, or if it's less than or equal to 0. Same thing with y. Check it against 0 and check it against max y. So if x is 0 or x is max x, or y is 0, so if any of these conditions are true, then this land is bordering on the edge of our map, so our result will equal false. This is not an island. All right. Okay, so what's next? We've checked to see if this is land, we've checked to see if we've already visited it, and we've checked to see if we are bordering the edge. Now, if we make it past this, then we've got some land and we'll want to check up, down, left, and right. So we'll check all of the land or all the cells that are surrounding this cell. So that's up. So everyone has their own way of doing this. I like to be explicit and have an up, a down, a left, and a right. So now our up, well, that's going to be our current x, and then y. Now again, this is 0, 0 up here, so up is actually y minus 1. So y minus 1 if y is greater than 0. Otherwise, there is no up. We're at the edge of the map. Down, it's very similar. It's going to be x and then y plus 1 if y is less than the maximum y. Otherwise, we don't have a down. We have left. Finally, right. All right, just double check these. So we have up, down, left, and right, but that's only if we have y greater than 0, y less than max, x greater than 0, x less than max. And this should be max x. Okay, and now I put these all in directions. So we can loop through these. So we have up, down, left, right, and then I can just say for my direction in directions. If d is not equal to none, or in our case we can just say if d, then we'll add this direction to our queue. So this is a little bit confusing, but it shouldn't be too bad. Basically, we're at some land cell. We're going to look up, down, left, and right, get the coordinates for all the surrounding cells. Then for each of those up, down, left, and right cells, if there is an up, down, left, or right, because again, if we're at this border, we're not going to have some, like if we're at the top here, we won't have an up cell. If we're at the bottom, we won't have a down cell. So if we actually have a direction that we can go in, we'll put that into our queue, and then we'll keep going. So that'll loop around, we'll pop it out of the queue, we'll check the XY coordinates, keep going, check all of the connected cells, so on and so forth. Now, one thing I just noticed I missed. I am not currently adding this anywhere to our visited list. So let's see. If we check and it's not in visited, then we'll continue. At this point, we'll want to add it to our visited list. Okay, so this should be it. Now, this is probably pretty complicated. I would recommend studying these types of problems because you'll find these grid traversals on many of these LeetCode problems. So once you have your basic template down and you know how to do a general grid traversal, then you can tailor it to your specific needs on any particular grid traversal problem. Okay, I am sure I'm going to have some typos, but I'm just going to double check and see if this will run. Okay, well, what am I missing? I don't need this other if. And we pass. Okay, we got 6 minutes. Yeah, I'll submit this, see how we do. And we pass. All right, so we do okay, not great. We beat 35% for runtime and 10% for memory. So it's a little bit memory heavy, but we do pass. So what can we do to make this a little bit faster? Well, we are doing a lot in here. There's probably ways to clean this up. One thing I can definitely do is get rid of this extra space here. So in these cases, we're doing our continue. So we can basically combine both of these if we wanted to. So if either one of those is true, we'll continue. I personally like this because it's easy to see what's going on, but this could probably be slimmed down to make this a little bit faster. What else can we do here? Well, we've got this. Well, let's see if we did one change here that did a combination. Let's see if it still works, and let's just see if this saves us anything. It actually makes things worse. Ah, nuts. All right, we'll undo that. Okay, let's try this. Sometimes, I'm not saying all the time, but sometimes we can do, instead of doing these continues, we can do an if and switch the logic here. So we'll say if the grid is equal to a 0 and it's not invisited, then we'll do all this. So let's try that. All right, so we're gonna indent all of this. So now we're saying if we actually have some land and we haven't visited it yet, then we can do this internal stuff. That cleans it up a little bit. We can also do the same here. So instead of saying if this is water or it's invisited, we'll say if it's not water. So if it's 0 and it's not invisited, then we'll check if it's an island. All right, let's see if this helps. All right, it does give us a little bump. We're now at 48% for runtime and 14% for memory. Love to get this over 50%, but one of the things that people do in these kind of situations, they will modify the grid itself. So one thing you could do, instead of keeping this visited set, you could actually use the grid itself, change the values in the grid. So notice a lot of places where we're checking if we're visited, we're also checking to see if we're land or if we're not water. So if we used one as quote visited or water, so you can ignore all the water or visited, we could actually go through and anytime you find some land, as we traverse through the land, we can flip these bits to be ones. That way it's going to look like water or visited, but it doesn't really matter because they're equivalent in terms of our search. The only problem that I have with that is this grid is passed by reference, which means the changes that you make in your function here will be reflected in that grid everywhere else this program uses the grid. So in our particular case with this test problem, it's not a big deal. Nobody else is using this grid. But in a production environment, if you are working with other people's code, people are passing around these data structures, these classes, and you're making changes to them, that could mess somebody else up. If they're expecting this grid to still represent the land and the water, and you're throwing in all these ones to basically just represent your visited state, then when somebody else grabs that grid, it's just going to be filled with ones, and they're not going to know what the land and the water were. So that's my soapbox rant, basically saying you could make this faster by repurposing this same grid. I don't recommend doing it, however. So with that, I think we're done at 48%. I challenge you to do better. All right, we're out of time. Hope you enjoyed this. Hope you had fun. Hope you can go out and write some better code.